Hello everyone, welcome back to our Terraform tutorial series. In the last video, we walked through creating a VPC using Terraform. We've set up a public and private subnets, internet gateways, and NAT gateways along with routing between these components, thus laying the foundation for deploying applications in AWS. In case you missed that, I highly recommend checking that out before continuing with this video, as we'll be building up on top of the VPC we created. In today's video, we'll be setting up the infrastructure for a WordPress installation. This helps us demonstrate the features that we have set up in the last video, plus the features of the components in this video. We'll use Amazon EC2 to host the WordPress website and Amazon RDS to create MySQL database where WordPress will store all its data. This is a great hands-on project to show how you can use Terraform to automate the deployment of cloud resources for a real-world application. Prior to starting this lab, I recommend that you have the basic understanding of EC2 and RDS services. I also recommend to watch the part 1 video, aka the VPC infrastructure. You should also have AWS CLI and Terraform installed and configured, with AWS profile configured with permissions to Amazon EC2, RDS, KMS, and Secret Manager. Lastly, you should also configure your SSH key for the EC2 instance. By the end of this video, you should have basic knowledge on how compute and databases within AWS function. You will also recognize how different components that we have created in part 1 work together once we have active compute instances running within our network. You will learn how to configure and launch EC2 instance while securing access to it through security groups. We will also go over on how to configure user data for our EC2 instance, which will automatically install necessary packages for us to facilitate our WordPress website. Following, you will learn how to configure RDS databases and go over some of the security features you would want to turn on. We will enable EC2 access to RDS through yet another security group. Lastly, we will install and configure the WordPress application itself. Let's briefly discuss each of the components used in this video. First of all, we have Elastic Compute Cloud, aka EC2, which is simply a virtual machine service in the cloud. It allows you to turn on virtual servers on AWS, offering flexibility in terms of configuration, operating system, and software. In this setup, we use EC2 instance to host the WordPress application, making it accessible over the internet. We'll use an EC2 instance in our public subnet for the web server, which will run Apache Web Server and WordPress. The EC2 instance will have a public IP address, allowing it to serve the website to users worldwide. Next up, we have Amazon Relational Database Service, aka RDS, which is a managed database service that simplifies tasks like scaling, backups, and patching for relational databases. For this project, we use an RDS instance to run MySQL, which we will serve as a database backend for WordPress. The RDS instance will be located in a private subnet, enhancing its security by restricting direct access from the internet. We'll secure the RDS instance with encryption using AWS KMS, which is Key Management Service, and configure access through a security group, allowing only the EC2 instance to connect to it. Security groups act like virtual firewalls, controlling the traffic allowed to reach your AWS resources. We'll use separate security groups for the EC2 instance and RDS. EC2 security group will allow incoming traffic on ports such as HTTP, port 80, and SSH, port 22, for web traffic and server management. We can also use port 443 to allow HTTPS traffic. However, in this video, I will not be setting up HTTPS for our deployment. RDS security group will restrict access to the RDS instance, as I've just mentioned, ensuring that only the EC2 instance can connect to it via MySQL's default port, which is 3306. Lastly, we have KMS. It's a managed service for creating and controlling encryption keys. In this setup, we'll use KMS to manage the encryption of the RDS instance's password. The RDS password is securely encrypted using KMS key, ensuring the database credentials are protected. That password will then get stored in a secrets manager. AWS Secrets Manager is a service that securely stores, manages, and retrieves sensitive information like database credentials, API keys, and other secrets, enabling automatic rotation and fine-grained access control. As we wrap up the components, let's briefly discuss the steps we will take in this lab. First, we will define the EC2 instance, specifying its AMI, instance type, key pair, and SSH access. The EC2 instance will serve as our WordPress web server. Then, we will create user data script to automate software installation and configuration when the EC2 instance launches. Following, we will define Amazon RDS instance using MySQL as a database engine. Once that is complete, we will set up security groups for both the EC2 instance and the RDS. At this point, all of the infrastructure declaration is complete and is ready to be deployed. Using Terraform, we will apply our configuration, which then will provision all of our resources. After connecting to the EC2 instance through SSH, we can complete our WordPress setup by configuring the database settings, adding security salts, and then restarting the Apache service. After testing and completing the project, we can destroy the entire infrastructure, and that will be the end of the lesson. Now, let's move on to the actual lab. To begin the actual hands-on part, let's quickly go over the variable that we've declared in the last lab but did not use there. The variable whitelisted IPs stores a list of IP addresses or CIDR blocks that are allowed to access our resources. In this case, it's used for whitelisting one specific IP that will be granted access to our deployment. Considering this is just an example lab, I don't want it open to the whole internet, but rather only to my own VPN's IP address. If in the future that list needs to be expanded, you can always update the variable with more IPs or simply allow all. Now that this was covered, let's move on to setting up our EC2. This is where the actual WordPress website will run. Let's start by creating a new file called ec2.tf. Within it, we will make a resource called AWS instance, and we'll name it public EC2. So now that the code is complete, let's discuss it. The AMI argument specifies the Amazon machine image that will be used to launch the EC2 instance. In this case, we are using the following AMI. This AMI is part of AWS's free tier, meaning it won't incur charges for smaller development purposes. An AMI is a pre-configured template that provides the information required to launch an EC2 instance. It includes the operating system, application server, and other software configurations. Essentially, it acts as a blueprint for your virtual machine. Next, we have instance type, which specifies the hardware configuration for this instance. We've chosen T2 Micro, which is free tier, eligible and suitable for small workloads, such as our WordPress application. Subnet ID argument assigns the instance to a specific subnet. We're using element AWS subnet.public subnets with a wildcard .id, 0 to place this instance into the first public subnet. This allows the EC2 instance to have direct access to the internet, which is necessary for our web server. The key name argument specifies the name of the key pair that will be used for SSH access to the EC2 instance. I have already pre-configured the SSH key for this lab and thus using the existing one. If you have not done so, I encourage you to do so before proceeding with the rest of the lab. The VPC security group IDs argument defines the security groups associated with the instance. We will assign security group for this argument once we create it shortly after this. Associate public IP address, just as it sounds, assigns a public IP address upon the creation of the instance. This allows the instance to be accessed from the internet, making it possible for users to view the WordPress website hosted on this server. The user data argument allows you to run a script automatically when the instance is launched. We will be using a script named userdata.sh to automate the installation of required software package like Apache, PHP, and WordPress and configure the server. So let's input the name here. Next, we have tags. The only tag we have here is the name tag, and the name of our instance will be simply public EC2 instance. We will also be defining two different output blocks. The output block will allow us to easily retrieve and display public IP address of the EC2 instance along with its DNS name. This will be useful for accessing the EC2 instance via SSH without having to look up the public IP address using the console or CLI. And the DNS name will allow us to use EC2 DNS name instead of the IP address to access our WordPress website once it is set up. Now let's continue the lab and make our user_data.sh file. I've actually forgot you need to put file function right here instead of just saying user_data.sh. And this will know to grab the information from the file. Another thing I've just realized is I made a typo right here, and instead of private subnets, it should be public. Let's fix that quick. Okay, now we can move on to creating the user data.sh file. And here I will just paste the predefined commands. Let's quickly go over them. It's pretty straightforward. First, it updates the system packages. Then it installs MySQL client and Apache web server. And then it starts Apache. Following, it installs dependency for PHP, which is required for WordPress. And then it downloads, extracts, and moves WordPress files to the web server directory. Lastly, it configures WordPress permissions so Apache can manage it. This ensures the EC2 instance is ready to host a WordPress site almost immediately after launch. Having defined the EC2 instance and the user data configuration, the next step is to establish security groups. First, we need to create a file for this. We'll call it sg.tf, and now let's type the code in. Now that the code is finished, let's discuss the security groups. Security groups allow you to specify who can reach your EC2 instance and the RDS database, ensuring that only the necessary ports are open for communication. Let's take a look at how to set up these security groups to protect our resources effectively. We will name the first security group public whitelisted, and we will use it for the EC2 instance in the public subnet. So here we have the name argument, which just simply gives the name for the security group. In this case, it's set to public whitelisted IPs, making it easy to identify its purpose. Description provides a brief explanation of the security group's intent. Here, it states that the group allows access via VPN, which indicates that it's configured for whitelisted IPs. VPC ID associates a security group with a specific VPC. The value is set to ID of the VPC created earlier in the Terraform configuration. This association is essential as security groups can only be applied to resources within the same VPC. Ingress block lets us create a rule to configure parameters for the traffic that is coming into our EC2 instance. Similar to the security group description argument here provides context about what the specific rule is for. In this case, it indicates that the rule is for allowing access from whitelisted IPs. From and to port define the port range for the rule. Here, both are set to 22, allowing SSH traffic specifically. Protocol argument specifies protocols such as UDP or TCP. In this case, it's set to TCP for TCP-specific traffic, which is typical for SSH and HTTP. CIDR blocks define the IP address ranges that are allowed to access the resource. The value var.whitelisted_IPs references the list of whitelisted IPs defined earlier, restricting access to only that one IP address. Egress block lets you configure parameters for the traffic that is going out of our EC2 instance. This security group rule allows all outbound traffic, meaning the EC2 instance can initiate connections to any IP address. This is typically acceptable for web servers as instance requires update for the operating system or installed applications. By permitting all egress traffic, instances can reach update repositories over the internet to download and install necessary patches and updates. Applications hosted on the EC2 instance sometimes also need to communicate with external services, such as APIs, content delivery networks, or database hosted outside of the VPC, and that's another reason to allow this outgoing traffic. The second security group, private RDS SG, is specifically for the RDS instance. Here, we only have an ingress rule for port 3306, as security groups make a stateful connection. This means that if an inbound request is allowed, like an EC2 instance connecting to the RDS database, the corresponding outbound response is automatically allowed as well, even if there is no explicit egress rule defined. Therefore, there is no need for a specific egress rule for RDS. The system handles it automatically. Databases typically do not need to initiate outbound connections for standard operations. They respond to queries sent from clients, which is why we do not have an egress rule. The only new argument here is security groups. This argument references the public EC2 security group, allowing only resources within that group to access the RDS instance on the specified port. This adds an extra layer of security by restricting access to the EC2 instance only. Since I already made a typo earlier, let's quickly go over the code and make sure there are no other mistakes. As I was describing port 22, which is SSH, as you can see, I've typed port 80, which is HTTP. Now that should be fixed. Also, I see a typo right here, which says TPC instead of saying TCP. Looking at everything else, that looks good. And now we can move on. As we've configured a security group for EC2 and RDS, let's quickly update the value for security group in our EC2 code and move on to declaring RDS. Here, Terraform resource will be AWS database instance, and we'll name it MySQL database. Notice here I messed up the naming, so we're going to change it back to private RDS security group. Now that the code is complete, let's quickly break it down. First, we have allocated storage, which is the size of the storage in gigabytes for the RDS instance. In this case, it's 20 gigs. Next, we have engine, which sets the type of database engine that will be used. As mentioned, we'll be using MySQL. Engine version defines which version of MySQL we will be using. Just like the EC2, instance class specifies the compute and memory capacity for the database instance. To put it simply, RDS is an EC2 instance with database configured for you, and it's managed by AWS. dbt3 Micro is a free tier eligible, making it cost-effective for small workloads or quick examples like our lab. Username sets the master username for the database. You'll use it to log in into the database. Manage master user password automatically manages the master user password through AWS Secrets Manager, increasing security and ensuring that the passwords are rotated and stored securely. Secret Manager, as the name suggests, is a service that securely stores and manages sensitive information like database credentials, API keys, and passwords, allowing you to easily rotate, retrieve, and control access to these secrets. Master User Secret KMS KID encrypts the master user password using AWS KMS, which stands for Key Management Service, further securing your credential. DB subnet group name associates the RDS instance with a specific subnet group, private subnets in this case, ensuring the instance is placed in the correct network. VPC security group IDs apply a security group that defines which resource can access the database. In this case, only your EC2 instance will have access. Database name is pretty straightforward. It's just a name for our MySQL instance. Identifier is unique identifier for the database instance. It's how AWS will refer to the specific RDS instance. Storage encrypted encrypts the storage for the RDS instance, ensuring that your database is protected, both at rest and during backups. We will also define multi-AZ capability, which will enable multi-availability zone deployment for higher availability. This means a secondary instance is automatically created in another availability zone for failover, improving our fault tolerance. We do not really need it in this case, as this is just a test app, but I did want to show you that capability. Then we have skip final snapshot, which disables the creation of a final snapshot when the database is deleted. This is useful during development as we do not want any extra charges for using app space for storage, but for production environments you may want to enable snapshots for backups. Let's move on to our output. Here we just want the value for the RDS endpoint. This block outputs the database endpoint, aka the URL, that you'll need to connect your WordPress application to the MySQL database. Again, this can be fetched from the console or by using CLI. However, it is just nicer to have these things handy as soon as you deploy to save some of your time. Our subnet group name is simply MyDB subnet group. As you might have seen, I first left the subnet group name argument empty, and then I created the subnet group. As I've mentioned, the AWS DB subnet group resource defines which subnet the RDS instance will use. This will ensure our RDS instance will be launched in private subnets. The last resource we will create is a KMS key, which will be our encryption key used to secure RDS database password and also to encrypt our storage. The only argument that this resource has is a description, and we have added value to master user secret KMS key ID argument in our RDS resource as soon as we created it. We can now apply our Terraform. Once the Terraform is finished applying, please take notes of the output values as you will need them shortly. Terraform Apply will take a while, so I will pause the video for now and I will restart it once it is done. As I mentioned in the first video, please make sure that you review your Terraform plan prior to typing yes and continuing on with applying it. As you can see, this apply took a while. I suspect it's due to our RDS being in multi-EZ configuration, and thus because there are multiple instances being deployed, it takes longer than if it would be just a single instance. Here we got our outputs, which I will quickly note before we move on. Actually, I want to show you a quick trick. If you have cleared a terminal by accident, you can always type in Terraform output in order to get your output. With our infrastructure fully set up, it's time to move on to installing and configuring WordPress on the EC2 instance. We'll begin by logging into the EC2 instance using the public IP provided by the output and your SSH key that you should have set up earlier. Once logged in, to connect WordPress to our RDS database, we first need to create database user. In your EC2 session, we will use MySQL environment variable to store the name of our endpoint, which has provided by the RDS resource output. So let's do that with export mysql_host equals to the URL of the endpoint right here. This allows the MySQL client on the EC2 instance to know where to find the RDS MySQL database by specifying its network location. The next step is to connect to the MySQL database on the RDS instance using MySQL client. We need to obtain our secret ID, however, we cannot do that without having access to the secret. There are two ways to go about it. We can either grant our EC2 instance permission to access the secret, or we can temporarily copy the credentials of our AWS user that we use on our host to the EC2 instance and use those. For the ease of setup, I will just do the latter. So in order to do that, I'm going to need to create two files, which is AWS config, I believe. Actually, let me check my host. Yep, there are two files, config and credentials. So I'm gonna create both of those files and just copy the contents from my host into my EC2 instance. And you can do the same. Oh, I'm not going to show you my credentials. I just encourage you to do that part yourself. And once I'm done copying my credentials, I will be back to continue the lab. As you can see by the commands now that I've configured my credentials, let's obtain our secrets ID with the following command. AWS secrets manager. And there is only one secret ID. Now I will just copy and paste this long command that I've created in order to retrieve secret without actually pasting it in the terminal. So let's quickly go over the command. Here we have the MySQL client command, which we specify the user with, which is admin. And then for the password, we actually specify an AWS command that retrieves the secret value by secret ID. And then we'll specify that we need secret string and we output as text. It then uses cut to only extract the secret value out of the secrets manager. So let's press enter. This should work. Unless it did not. Let's see. Word. Okay, so as you can see, I've made a typo in the database name. I've missed the P, and it says WordRest instead of WordPress. And as such, we need to accommodate for that. And now we're in our MySQL. Now that we've logged into the database, we need to create a database user for the WordPress and assign necessary privileges. You will execute the following SQL command after logging into the MySQL database. Here, I'm just using a very strong password, as you can see in an actual production environment. Please use a strong password. Here we need to modify the database name to accommodate for the typo that I've done earlier. Now let's see. I'm going to debug this error, not sure what happened. And let's log back in. By accident, I have actually modified the username and not the database name. So here, it needs to be WordPress. And here, it needs to be WordPress, accounting for that error. And the command ran successful as it logged us out from the database. Let's quickly go over the command. So create user, as the name suggests, creates a user WordPress. Identified by specifies the password for that user. Grant all privileges, again, pretty straightforward. Grants all of the permissions on database called WordPress and all its tables to our WordPress user. Finally, flush privileges ensures that MySQL applies the new user permissions immediately and exit, as the command suggests, exits the session. Next, we need to edit the WordPress configuration file on the EC2 instance to connect it to the RDS database. Let's go to that file. The file name is called Wordpress Config.php. And here we're going to need to use sudo because, as you remember, from our user data.shell file, we've granted all of the rights to our web user Apache. Let's use sudo. And here we will need to modify the following lines. So for the database name, we will put WordPress. For the username, we will put WordPress. For the password, we will put our password. I actually encourage you to find a way to not store the password in the configuration file that is here and find a better way. And for the DB host, again, we put our RDS WordPress URL. Now that we've configured the database settings, the next step is to enhance the security of our WordPress installation by setting up authentication unique keys and salts in the configuration file, well, the exact same file that we've just edited. These keys and salts are used by WordPress to secure cookies and password hashing, making it harder to compromise your site. WordPress provides a tool to generate these securely. You can retrieve them by running the following command on your EC2 instance. It just queries their website and you get all of the information that you need. So let's just copy that and go back to the config file. Let's remove all of these. And this should complete your installation. You can now restart the Apache service. If you go to the DNS of your EC2 instance, you should see your WordPress installation. Well, the command to restart the Apache is sudo service httpd restart. Now, if we go to our EC2 URL, we technically should see our WordPress website. As you can see, everything went successfully, and you can see the WordPress installation. At this point, the practical part of the lab is done. I am not going to continue with WordPress installation. However, I encourage you to do so if you wish. Now that we are done using these resources, let's run Terraform destroy in order to get rid of provisioned resources. That way, we don't overpay any charges. To destroy resources, you simply run Terraform destroy. Just like creation, Terraform destroy also takes a while. So once the plan runs, I will just skip the video forward when it's destroyed. And here we type yes. As you may have noticed, the longest resource took to destroy again was the database. However, it took a little less time than when actually applying. Now that all of the resources are destroyed, on to our conclusion. Now that we've successfully set up the infrastructure and walked through the connecting WordPress to the RDS database, it should be a bit more clear how various components such as VPC, networking, EC2, RDS, security groups, and encryption come together to create a secure and scalable cloud environment. By using Terraform, we were able to automate and streamline this process, saving time and ensuring repeatable, consistent deployments. In conclusion, we've demonstrated how to not only launch infrastructure but also securely manage it with best practices. While this setup is great for learning and small applications, it's not yet production ready. For production, you would want to consider additional factors such as high availability, scaling, automated backups, and enhanced security measures like strict policies, and monitoring tools like CloudWatch.